So in this video, we'll check out a couple of the pieces of a problem from the 2007 AP Calc AB exam. This is problem number 2 that we're going to be checking out here. And it's a calculator problem. And the situation that's set up here is that we have a storage tank and there's water within the tank. The amount of water, the volume of water in the tank is going to be being measured in gallons here. And it's modeled by a continuous function over the time interval 0 to 7. Our units of t are going to be hours. This model, the rates are given by f of t and g of t. And f of t is the rate at which the water enters the tank, holds from time 0 to time 7. G of t is the rate that water leaves the tank, and that's a constant 250 between 0 and 3 hours, and then at t equals 3 shoots up to 2,000 gallons per hour, and that's going to hold the rest of the way till t equals 7. They give us the graph of f and g to work with here to answer our questions. And they tell us the intersection points too. So they tell us that this intersection right here is at a t-value of 1.617 and that this intersection point right here is at a t-value of 5.076. We also know that we've got 5,000 gallons of water in the tank at the beginning of the time frame. What they ask us to do in part A is to determine how many gallons of water enter the tank during the time interval from 0 to 7. Round your answer to the nearest gallon. And so we're not asked how much water is in the tank at the end of time t equals 7 or from 0 to 7. We're not asked to figure out anything with regard to how much water leaves the tank. It's just how many gallons of water enter the tank. Well, the rate at which water enters is given by this function right here. And if we integrate that rate of change across the appropriate limits of integration, which are specified for us in the problem statement for part A here, our result is going to have units where the function value would be measured in gallons per hour. The differential right here is going to have the same units as the independent variable. That would be hours. Those cancel. Our result is going to be a certain number of gallons. And that number of gallons, since it's an integral of the rate at which water enters, that's going to be how much water actually enters the tank over the course of this time frame. Now, when the calculator is in play, don't waste your time doing an integral like this by hand. This is actually a function here that you will not be able to develop an antiderivative for very efficiently, if at all. So what we're going to do is we're going to go into the math menu of the calculator, grab our integral feature. Now on the TI-83, which you see me using here, this is a little bit clunky. So if you're using a TI-83, the call sequence is to get the function that we're trying to integrate in first. So that'll be 100 times, I'm going to swap out the t's for x's, so times our variable squared, and then times sine of that variable, square root of that variable. So I'm going to close my root, whoops, that's not how I would close the root. That's how I'd close the root. Close the sine function. I'm not going to close that set of parentheses. Once you get the function in, once you get the integrand typed in, you give the calculator a comma, you tell it the variable of integration, you give it another comma, you tell it the lower limit of integration, you give it another comma, you finally tell it the upper limit of integration. Now I'm going to close this initial parenthesis that they gave me here, and calculator is going to do all the work, and it thinks for a minute or so, and we should have the value of this integral before too long. And then we would just round that to the nearest gallon, I think, right? It does say round to the nearest gallon here, so we'd be looking at 8,264 gallons entering the tank over the course of the time frame from 0 to 7. In part B, they say we want to determine the intervals when the water level in the tank is decreasing. And so if you think about it this way, the water level in the tank is going to be going down or decreasing if water is leaving at a higher rate than the water is entering. So whenever g of t is above f of t, the overall water level in the tank will be decreasing. So that definitely happens on the interval from 0 to this intersection right here. That intersection is at 1.617. There will be a certain amount of water in the tank at 1.617, and we could compare the amount of water in the tank at 1.617 with the amount at 1.616, and we will see we have more water in the tank at this time than we do at the time immediately to the left of this x. And that's why we're able to include that endpoint on that interval. We also have another interval where the function g of t is above the function f of t. And that happens on the interval from 3 the rest of the way to this intersection right here. And that would be 3 to 5.076. Now it's really kind of sneaky here. As you see, I've included the endpoint of 3, and the rate of change the rate at which water is leaving the tank isn't even defined at 3. So it might be tempting to try and say, well, I'm going to have to put a parenthesis right here and have that as a half open, half closed interval. But think about it this way. There will be a certain amount of water in the tank at t equals 3, and that amount of water in the tank at t equals 3 is going to be slightly less than the amount of water in the tank at 3.001 hours. So since that amount at 3 satisfies the definition of a decreasing function, since there will be a certain amount of water in the tank at t equals 3, and that amount of water is less than any amount of water for a t value immediately to the right of this t value, we're allowed to include it within that interval. Same thing for this endpoint as well. Truthfully, when they graded this on the actual AP exam, they didn't penalize you if you listed these as open intervals or half open, half closed. They basically just wanted to make sure you had the right intervals listed, regardless of whether or not you included the endpoints. Technically, based on the arguments we just made, the endpoints should be included, and that's definitely what you see if you go look up the College Board scoring guidelines for this particular problem. I've done part C in another video, so we'll wrap this video up here. And hopefully you found that helpful.